So I would like to give the floor to Joshua. So if you're ready.
Yeah, thank you. So I'm Joshua. I'm from Lübeck in northern Germany, and I'm employed through the Medical Informatics Initiative that we have going on in Germany. And I'm very excited to talk about a system I've implemented called BabelFSH today. So I work in the service unit terminological services that we have in the Medical Informatics Initiative. And well, the end goal of the MRI is basically to bring pretty diverse kinds of primary systems together through the use of FHIR and other harmonization processes across Germany. And that's a map of all the sites we have. I live here. And the service unit terminological services, or SUTermServ, that's a sub-project that we have in the MRI. And we are tasked with providing a national brackets research terminology service using CSIRO onto server. I see Michael sitting right there. And we have a collaboration between Lübeck, of course, Cologne, and Hanover. We are funded through 2027, started with the SUTermServ anyways in 2023. And my responsibility is basically to provide this terminology service to, well, Germany. Our content on the service is derived from national profiling initiatives, like the core data set that has been defined in the MRI starting in 2020, I believe. And there are a number of other profiling initiatives that we have going on concurrently, for example, ESIG and others. And there's going to be a very interesting talk, I think on Friday, from the German community as well, about bringing this a bit closer together. But anyways, our service basically is centered around the MRI stuff. And that's a screenshot from our staging server, actually. So for the 2025 version from OntoCommand. And as you can see, we have a lot of code systems and even more value sets, not that many concept maps, of course, because no one really defines them. But still, despite the large amount of data that we have, our biggest challenge is still content, because our users expect quite a lot from a terminology service. This is a survey we ran actually before the project started in 2022. And if you know those terms, you will know that most of them are not native FHIR resources. And well, everyone expects this FHIR terminology service to basically address all their problems. But as I like to say, that any terminology server that doesn't have the correct resources at the right time and defined maintenance processes is actually quite worthless. So we actually have to generate our resources somehow from the original sources to the FHIR representations. And I wrote some of the converters myself. There are others like those defined by CSIRO. And if you look at them, you will notice a commonality. First, all converters define metadata, and then they add content. And depending on the coffee level of the programmer, sometimes you do it in a hard-coded fashion. Sometimes you are a bit more considerate about what you're doing. You're not hard-coding quite as much, but still, it's not really a flexible system most of the time. So then you discover FHIR. Everyone loves FHIR, and there's a very good reason for that, because it makes profiling so much nicer. And it's really good at defining metadata. But turns out that if you want to convert a large resource using FHIR, or SUSHI rather, into FHIR CodeSystem, for example, you will be waiting for quite a long time. And then the galaxy brain moment was basically the realization that FHIR is just a standard that's maintained more or less independent of FHIR. And SUSHI is just a rather good reference compiler, and you're not required to actually use SUSHI rather. But what SUSHI also does, because it's open source, it provides a really convenient end-level grammar. So what you could do is just write your own system, massage the FHIR syntax just a little bit, and then you have your own system that's quick and powerful for terminology conversion. So this is basically what that looks like. I've called the system BabelFSH. I'm pretty proud of the logo too. And it's centered around the plugin architecture. But as you can see, this is just normal FHIR stuff, where you define the metadata of the resources you want to generate in FHIR. You can use rule sets and all that, of course. And then for the content stuff, there is a plugin architecture. And because we decided that we didn't want to break the fish syntax itself, we basically put all of that magic into kind of structured comments. And if you've ever used a Unix system, you'll know this. This is actually a command line call. So basically all plugins, compile time plugins anyways, define command line parameters. Some of them are required, some of them are optional. There can be interdependencies, of course. They all have help texts. And basically this plugin is then called to generate the terminology resources you need from the original sources. And all of the complexity of generating that should be put into that plugin. So this is how it looks like on a high level. Again, this file is read by BabelFSH, and then once the metadata is read, there is a scaffold that's generated and validated as well. And then this is put into the, into the plugin you've referenced through the plugin ID here, CSV. Has a really simple API too, so it's really easy to define your own plugins. Then it knows that it has to read the input CSV, which is referenced here. And then through the metadata scaffold and the plugin, the end resource is generated. Those are the kinds of CodeSystem plugins I've currently implemented. Those are the core plugins, as I like to call them, the general stuff. And two of them are actually using the code from the good folks at FHIR, because Apache 2 does allow you to do that. I've basically hacked in a bit of codes to hook into this fish parser, but otherwise it's just the core logic that you all have provided. CSV is really flexible. I consider everything that's more or less tabular with a separation character as CSV. And then there's some other stuff like XSLT, which is nice for transforming XML code systems. Basically, the style sheet maps to a defined schema, and then that's converted in the plugin to FHIR CodeSystem. Sounds weird, works well. And then there are some specific plugins we've also implemented based on our requirements from the Medical Informatics Initiative. For example, EDQM standard terms. If you've ever called that API, you will know the pain of authenticating to that. But you can write your own plugin to that. You can test it. And then it just works, basically. And we've actually ported our implementation from Python to BabelFSH, and that worked well. Took about half a day, maybe, for just porting this. Another thing that's really nice is that this could actually serve to basically streamline provision of terminologies where you don't really have the license stuff figured out. For example, Medra is something that we are actively talking about right now. There are extensive license gates. They are very restrictive about their IP, and it's not allowed to distribute something from the resources they provide. But if we could at least provide a standard generator for FHIR CodeSystem, that's not quite as good, but it's getting there. And then we can also maybe go to MSSO, basically donate this converter to them, and then they would be able to offer FHIR CodeSystem for this subscribers. Something to think about anyways. We also have implemented ConceptMap generation just from CSV to ConceptMap right now. Again, based on requirements from the Medical Informatics Initiative. It's a bit of a different thing to what the onto-server folks are doing with Snapper, because it can handle much larger mappings as well. And we can also generate code systems from the same spreadsheet. Of course, there's opportunities for other kinds of concept maps. And of course, if you know the differences between CM in R4 and R5, well, we have decided that we don't want to do auto mapping for equivalence to relationship because they are just a bit too different. So the mappings have to take that into account. Well, we can talk about that later anyways. So about the implementation details, it's written in Kotlin. I like that language quite a lot. There is, of course, the entry-generated stuff and the Java code from CSIRO in there as well. We are using Gradle and BabelFSH is licensed under Apache 2. We use quite a bit of key libraries, and actually I have to add one of them, which is the core validator that Graham provides. But again, Antler is really important. FHIR for low-level validation, or yeah, for rule validation, and then the core validator for basically the entire profile, so that you might use like shareable CodeSystem, and some others that are really important for providing this. And of course, if you want to provide your own plugin for this, you are free to add whatever you require to get that done. So this is our GitLab link. The QR code should point there as well. And during the last week, I've started working on a bit more documentation. So this is still quite work in progress. But again, since every command line also defines its arguments or help text for the arguments, there is a facility for interactive documentation as well. And performance, we got that down as well. So alpha IDSE, that's an alphabetic index to the German modification of the ICD-10 that has about 90,000 concepts in the 2025 version. And that's running in real time. That was actually before I put FHIR validation through the Graham validator in there. So if you call that, it might be a bit slower, but this single version, oh, actually, sorry, this is converting 10 versions of alpha ID in about 10 seconds. And if I ran that using SUSHI, well, I would have just about time during my talk to do that when the computer is idle on this pretty nice laptop. So it took about 30 minutes. And that can really help integrate this into, for example, automated delivery systems as well. So some more ideas to come to close. Again, I talked already about using this for stuff like Metra. I've already talked to some people about providing some kind of SQL adapter as well. Those using legacy systems love it, because that would be really easy to basically provide your catalogs or whatever you call them in your legacy system in this new FHIR world. And one thing I haven't tackled so far is ValueSet support either. Well, I would love to discuss it with some of your, if this is just something that should be implemented for extensional value sets, because I feel like intentional value sets are handled better by SUSHI, right? Because it's a really good system for that. But extensional stuff from original sources, I think that might be really interesting as well. So yeah, I'd like to thank you very much for your attention. And of course, do scan the feedback link. And again, the left QR code is for the Git as well. Thanks, y'all.
Nice. Time for questions. Are there any?
Thanks very much for the talk. Can you just speak a little bit more about how you're using ConceptMap and what the generation of the ConceptMap results in?
Yeah, sure. So the use case was basically that we had a content enforcement system in our data integration center, and they had to map from one representation to another. So the experts who knew their stuff much more than I did basically provided an Excel spreadsheet, which had like the old code, the new code, and then some other stuff. And then once you add the equivalence or relationship for R5 in there, you can use this spreadsheet to generate both a code system for your internal codes, a code system for the external codes or whatever, and then the concept map that maps between them. So it's a really nice way to bring like expert consent mappings, because experts love Excel, of course, to the FHIR world. That's also what the OntoServer folks thought about when you all implemented Snapper, and I think the concept is really nice. So this is just an extension of that idea.
Hi, yeah, thank you for the talk. I have a question regarding the code systems that BabelFSH generates. You mentioned that you had an example there with 90,000 concepts. Did I get it right? That the result would be a JSON file containing all the 90,000 codes.
Yeah, that's basically what FHIR CodeSystem does. It didn't used to be that. So if you go back in history in FHIR to DSTO1 or DSTO2, you'll notice that there wasn't actually a CodeSystem resource. That was only added, I think, in DSTO3. You might know that better, Michael? Yeah, because the original idea was that external code systems, they have their own maintenance cycles and platforms and whatever, and that should remain that. And if you needed like domain-specific codes, you would define those inline in a ValueSet resource. So for stuff like the value absent reason code system, for example, that would be defined as a value set in DSTO2. And then those codes that are listed in that value set, those are manifested through their existence in that value set. And then very smart people, like probably including Michael, thought that this might be a really good opportunity for bringing this into a terminology server as well. So that's when CodeSystem was created. And yeah, it might not be the best distribution format. There are gaps and you can't cover all use cases. So for example, it's absolutely not possible to represent all of UCOM as a FHIR CodeSystem. You could define a fragment that defines commonly used codes, but UCOM is not representable at all. Some of it is challenging. You can get a long way, but not all the way. But yeah, that's what FHIR CodeSystem does, basically.
Okay, thank you.
I think you also had a question, right?
Yeah, one of my questions has already been answered. I was going to ask what's the output, but here maybe for the source, you said the many. I've seen in the table that as a source you can have many CSV files, maybe in a folder or directory.
I think that was for Metra, right?
Okay, yes.
Yes, so basically, when you define your own plugin, you will have to think about what is the input, how does it look like, how is it structured? Do you have to read more than one file? And then, of course, you can do that. And there's like a standard API for reading CSV in there, which is used, for example, also by this ISO country code stuff. Similar logic for the Excel reader as well. So there's a bit of reusable stuff in there, but still, if you have a specific use case, you will have to write your own plugin, same as you did before I created BabelFSH. But it's, I think, easier to bring it to this ecosystem because you don't have to think about metadata definition.
Okay.
And you have a simple API to target because this is actually complete. There might be differences for representation in R4 and R5, but otherwise it's basically the same logic. Same goes for ConceptMap, of course.
A really nice talk. I was just wondering, I saw ICD 11 in your list of things in the ecosystem. Have you applied it to ICD 11?
So I know some people at BFARM, which is our German regulator, and they have told me that they massaged the WHO to think about providing a FHIR resource for ICD 11. So I think this might not be needed. And as far as I know, currently there is no real machine-readable version of ICD 11, so no.
No.
And I hope that I don't have to do it.
Yeah. And what about OMOP?
There's actually an example in the repository which takes the CSV files from Athena and then generates code systems from that. That's possible because there's like a facility for filtering CSV files in the CSV plugin. Because again, I thought about making this as general as possible. So you can do, for example, generate a flattened version of Summit from the Athena stuff. Yeah. But mappings, that would also be really interesting to bring that into FHIR, yeah.
Okay, we're at our final question. So,
thanks for your talk. Any insight why SUSHI is so slow? Because I can imagine in that diagram that you have, like that CSV tag, you could just put all the SUSHI lines there and then let the SUSHI does all the job. But you're saying that it's much slower doing that, right?
I tried that for the paper I'm actually writing right now. And those 90,000 concepts, because they also define properties, those balloon to about 500,000 lines of code for a single version. So reading that takes, I think, around 13 seconds, and then converting that, because SUSHI is just not geared for that. It's not streaming in any way. It's basically reading all that into memory, and you can really feel that it's just thinking about it quite a long time. And the architecture of BabelFSH is geared towards terminology conversion. So it's streaming much more. It's not really serializing all of those concepts until it needs to. And that's just a very different kind of requirement that SUSHI has and that BabelFSH has.
Okay, let's give a nice round of applause because we're at the end. Yeah.
Thank you.